This video is the first video in the exponential unit. It is on sequences and patterns, specifically geometric versus arithmetic sequences. For this part, we're going to break down the differences between arithmetic and geometric. An arithmetic sequence would be 2, 4, 6, 8, 10. So what you realize is that it is being added to each time. The geometric sequence is 2, 4, 8, 16, 32. That means that it's being multiplied by 2 every time. That leads us to our first difference between the two. An arithmetic sequence is a constant difference, meaning you're going to add or subtract the same value every single time. A geometric sequence is a common ratio, meaning you're going to multiply or divide the same number every time. Many times you'll be given the numerical sequence and asked to find either the constant difference or the common ratio. We are now going to graph the two different sequences so that you can see the difference of the look in the graphs. The arithmetic is going to be green and the geometric is going to be blue. I'm going to start by graphing the arithmetic sequence. We see that the arithmetic sequence creates a line. Now let's see what a geometric sequence looks like. We see that the geometric sequence created a smooth curve, also known as exponential. You will need to be able to tell the geometric arithmetic sequence from a table, from a graph, or from an equation. So I'm going to teach you guys how to find the equations of these two tables. For the first one, an arithmetic is a line. And so the equation is y equals mx plus b. So what we first look at is, what is the difference? What is the constant difference on the y values? So if we're looking 5 to 2, I went by a -3. 2 to -1, I went by a -3. -1 to -4, I went by a -3. And -4 to -7, I went by a -3. You also want to check the x's just to make sure that they are going by the same value as well. And this was the +1. And from -1 to 0 is a +1. 0 to 1 is a +1. And 1 to 2 is a +1. So my constant difference is -3. That is your m value, or your slope. Your b is where you're beginning, and so your b is wherever x is 0. So in this case, my b is -1. So what that means is my equation is going to be y equals -3x minus 1. For a geometric line, we use the equation y equals a times b raised to the x power plus c. A is the initial value. B is the rate. And c is the asymptote. The initial value is wherever x is 0. So my initial value is going to be 2. My rate is what's changing for my y. So how do I go? Remember, geometric is a common ratio. So how do I get from 1 to 2? Well, I multiply by 2. 2 to 4, I multiply by 2. 4 to 8, I multiply by 2. And 8 to 16, I multiply by 2. So my rate is 2. So my equation is going to be y equals my initial value of 2, my rate of 2 to the x power, plus c. C is where the line is approaching. So if I look at this line, my line right here, it's approaching 0, but it never actually touches 0. So in this case, my C is 0. And that would be my equation for my geometric